100BaseVG. 100BaseVG is a 100 Mbit/s Ethernet standard specified to run over 4 pairs of Category 3 cable also known as voice grade, hence the VG. It is also called 100VG any because it was defined to carry both Ethernet and token ring frame types. 100BaseVG was originally proposed by Hewlett-Packard, ratified by the IEEE in 1995, and was practically extinct by 1998. In 2001, IEEE recorded the status of its 100BaseVG standard as being a withdrawn standard defined as a standard which is no longer maintained and which may contain significant obsolete or erroneous info. Standardization. 100BaseVG started in the E800 2.3 committee as fast Ethernet. One faction wanted to keep CISMA/CD in order to keep it pure Ethernet, even though the collision domain problem limited the distances to 1/10 that of 10BaseT. Another faction wanted to change to a polling architecture from the hub. They called it Demand Priority Protocol in order to maintain the 10BaseT distances and also to make it a deterministic protocol. The first faction argued that, since E800 2.3 was the Ethernet committee, it was not the place to develop a different protocol. Thus, the E800 2.12 committee was formed and standardized 100BaseVG. Physical layer. The physical layer requires 4 twisted pairs of voice-grade cabling for a link, so Category 3 cables, or better, can be used. While control signaling uses 2 pairs for each direction simultaneously, all 4 pairs are switched to a single direction during data transmission, as required and defined during control signaling. This makes 100BaseVG an inherently half-duplex medium like e.g. 10BaseF, yet faster, but without the CISMA/CD drawbacks. 100BaseVG also supports full duplex operation over optical fiber or over 2 pairs of shielded twisted pair. 100VG any LAN/VS. Fast Ethernet, Fast Ethernet. Multiplexing. Instead of following the fast Ethernet standard for twisted pair cabling by using only 2 pairs of wires, 100VG any LAN used all 4 pairs in either Category 3 or Category 5 twisted pair cable. The design goals were to avoid the radio frequency radiation emitted at the higher frequencies required by fast Ethernet and to leverage existing wiring installations of Category 3 cabling that most organizations have. This had the additional advantage of being less susceptible to external sources of RF interference such as other network cables, fluorescent lights, and high-power lines. They multiplexed the signal across all 8 wires, thereby lowering the frequency and making it more robust. This presented a problem with early installations that borrowed 1 unused twisted pair for telephone traffic, but those installations were uncommon. Deterministic. When Ethernet became fast Ethernet, it continued to use the carrier-sense multiple access with collision detection CISMA/CD mechanism to manage traffic on the network cable. 100VG took advantage of the token passing concept that made ARPANET and token ring popular in order to provide consistent performance no matter how large the network became. It removed the token passing responsibility from the wiring and network nodes and placed it internal to the 100VG any LAN hubs. These hubs contained the rotating token that never left the hub itself. When a node wanted to transmit data, it would raise a bit on its hub port connection, that indicating to the hub that it was ready. As the token passed by a ready hub port, it would then open up traffic to that node. Because the token stayed within the hub, it did not have to traverse long cables going to every node as in ARPANET and token ring, therefore becoming faster than those other deterministic networking standards and being less susceptible to cabling problems, network card failures, and line interference. Real-life load testing showed 100VG any LAN reaching 95% of its theoretical network speed instead of about 45% as in fast Ethernet when using hubs. Fast Ethernet switches were not commonplace at first because of high cost and limited availability, so, initially, 100VG had a significant performance advantage. References equals